Assalamualaikum warahmatullahi wabarakatuh. We are students from Engineering Fluids Mechanic Lab. Today I want to present about the experiment number 3, which is a friction loss in pipe. We are from section 2. So our lecturer is Mohd Fadzil Faisae bin Rashid. So this is our group member. So for abstract, our group had conduct and come up with this report for our third experiment to make the requirements of the topic Engineering Fluids Mechanic Laboratory with code BMM3521. The title of this experiment is Friction Loss in Pipe. This experiment is separated in two parts, which is experiment 1 and experiment 2. The purpose of this experiment is to determine the mechanics of fluid friction phenomenon in pipe and to understand the basic knowledge of the major loss in straight pipe and the minor loss. We are conduct the experiment with different type of pipe. The apparatus that we are used to carry the experiment are fluid friction apparatus, hydraulic bench, pressure sensor, data measurement, and data acquisition. At the end of this experiment, all the data such as the velocity, Reynolds number, coefficient of the friction, and heat loss with different condition and the level of degree was used.
My name is Ahmad Zulhilmi bin Muhammad Zaki and my metric number is MA1904. I want to present about chapter 1, which is introduction. So for background, in general, components affect the flow by changing the direction of flow, obstructing the flow, and changing flow speed through varying the cross-sectional area of the pipe system. Pipe system may have many components. Bend, elbows, and teeth are devices that change flow direction. Valves are used to adjust flow rates. Expansion and contraction are used to slow down or speed up the flow and may occur suddenly or gradually. Extraction into pipe system from reservoir and exit from pipe system into reservoir are also considered to be a component. Many components are used in this experiment, such as the elbow pipe, bend pipe, straight pipe, and sudden 45-degree angle pipe shown here, cause the flow to change direction rapidly. If flow direction change too rapidly, regions of separated flow are generated where adducts form, as hanging loose in components. The calculation of Reynolds number is used to assess whether the fluid flow is laminar or turbulent. The various environment and scenarios in real life are taken into account while considering head loss in pipes. In general, when the viscosity of the liquid increase, so does the heat loss in the pipe, especially at the fitting, which might result in a decrease in flow rate. The problem segment is major loss occur when a pipe valve bend or other disturbance occurs inside a pipe, whereas small loss occur when a pipe valve bend or the disturbance occurs. The flow velocity, pipe length, pipe diameter, and friction factor based on the pipe roughness as well as whether the flow is laminar or turbulent are all factors to consider. The presence of resistance generated by fluid flowing through pipe, pump, and fitting is referred to as friction loss in pipe. The internal energy of the fluid increases when the frictional head is lost. Friction loss varies depending on the type of pipe. End users should benefit from lower energy costs, less maintenance, and higher productivity if a piping system is efficient. Unfortunately, blockage may inevitably arise, delaying or obstructing fluid movement inside the piping system. We research the physics of fluid friction phenomena in pipes and apply basic understanding of major loss in pipes in this experiment. To address the problem, friction loss in pipe are measured. For objective, it consists of 3 points, which are to calculate the major and minor loss based on fluid flow in various pipe systems, to determine the value of velocity for various pipe diameter, and to accurately utilize Bernoulli's equation in determining the major and minor loads. And the scope are controlling the volume of fluid flow in PVC pipes with a fluid friction apparatus and hydraulic bench. The desired pipe will be fitted with a pressure sensor, calculating the pressure using data measurement and data gathering.
Assalamualaikum, my name is Ajwad, NA19149. So I will present the theory for this lab. Losses in pipe networks could be divided typically into major and minor loss. Major loss are produced mainly due to friction or viscous action, while minor loss are due to valve, fans, bubbles, sudden expansion, or contraction. So major loss. Major loss is proportional to L over D ratio and velocity head. For low velocities where the flow is laminar, friction loss is caused by viscous shearing between seamline near the wall of the pipe and the friction factor. For high velocities where the flow is fully turbulent, friction loss is caused by water particles encountering irregularities in the surface of the pipe, and friction factor itself is a function of surface toughness. So, in most engineering applications, the velocity is less than the required for fully turbulent flow, and it is a function of both viscosity of the boundary layer and the roughness of the pipe surface. Minor loss. It behaves similarly to major loss, where a device with a large K value lends to a high pressure loss in general. A very sudden change to the flow path contributes to significant pressure loss.
Assalamualaikum and a very good day. My name is Muhammad Akram bin Jamal Akbar and my ID number is MA19099. So today I would like to present to you method and procedure. So first we will go to the apparatus. We have 4 apparatus to run this experiment. The first one we have the fluid friction apparatus. The second one is hydraulic bench. The second one is pressure sensor. The third one the pressure sensor, and the last one we have the data measurement and data acquisition. All these apparatus you can see in the picture that I put in the slide. Next we go to the procedure. So before we start the experiment, we need to check the apparatus to ensure that the apparatus were in a good condition, especially on the fluid friction apparatus. Then we can start by open the valve system by turning it to left. Next we switch on the pump to allow the water flow. We can adjust the volume water by using the control valve until the desired volume is achieved. Any unused valve we will close, and we will leave only the valve for the purpose of experiment only. Next, we will install the pressure sensor at predetermined position to measure the pressure of the water. The value of flow rate of water on the flow rate indicator is recorded and tabulated. The last one, the step 1 to step 7 is repeated by using 90-degree elbow pipe, 90-degree bend pipe, and 45-degree bend pipe. I think that's all from me. I will pass the presentation to the next presenter. Thank you.
Hello everyone, I'm Kaovinath son of Appalasamy. My metric number is MA19055. And today I'm going to present about the results for the experiment. So the given informations are the length of the pipe, the internal diameter, thickness of the pipe, the density, the dynamic viscosity, and the area. So with this, for the first experiment, which involves straight pipe, the sample calculation as follows. So the flow velocity is calculated using this formula, and the Reynolds number using this formula, pipe friction using this formula, and calculated head loss using this formula. And this is the final results as in the table. So the volumetric flow and measured head loss was given, and these four parameters was calculated using the formulas which was shown before. So this is the graph for the measured head loss against the and calculated head loss against the Reynolds number. Okay, so from the graph, we can observe that the value of measured head loss and calculated head loss increases as the velocity of the water increases. So the head loss is directly proportional to the velocity of water in straight pipe. Second experiment was conducted using elbow 90 degrees. So the sample calculation are as follows using these formulas, these four factors, the flow velocity, the Reynolds number, pipe friction, calculated loss coefficient, measured loss coefficient, equivalent length, which is using the loss coefficient, which means the measured loss coefficient, and the equivalent length using the calculated loss coefficient. So these are the formulas used for the calculation. This is the final table for the results. And this is the graph for measured loss coefficient and calculated loss coefficient against Reynolds number for 90-degree elbow. From the graph, we can conclude that both measured loss coefficient and calculated loss coefficient depends on the Reynolds number. Both are inversely proportional. If Reynolds number increases, the loss coefficient, both loss coefficient will decrease. Third is the bend pipe 90 degrees. So this is the sample calculation and the formulas are same with the elbow 90 degrees, just the values are different. And this is the final table for the result for the pipe 90 degrees. And here, the graph of measured loss coefficient and calculated loss coefficient against Reynolds number, but this one is for bend pipe 90 degrees. So from the graph, we can observe that as Reynolds number increase, both measured and calculated loss coefficient will decrease. Therefore, loss coefficient depends on Reynolds number and they are inversely proportional. And finally, the bend pipe 45 degrees. So the same calculation, the same formula with different values. So this is the final table for the results. And here, okay, so this is the graph of measured loss coefficient and calculated loss coefficient against Reynolds number. This one is for bend pipe 45 degrees. So from this graph, we can see the relationship between measured loss coefficient and calculated loss coefficient, which is inversely proportional to Reynolds number. Because as Reynolds number increase, both loss coefficients will decrease. So here comes the discussion. First question is, what is Reynolds number? Reynolds number is dimensionless number, plays a prominent role in foreseeing the patterns in fluid's behavior, whether the fluid flow is laminar or turbulent or transient. It is one of the main controlling parameters in all viscous flows, where a numerical model is selected according to pre-calculated Reynolds number. Second, what is the difference between loss coefficient and the friction coefficient? Loss coefficient is a dimensionless number, measures the minor loss to the change in velocity due to friction through pipes, fittings, valves, While friction coefficient is a dimensionless quantity also, which is used in the Darcy-Weisbach equation for the description of friction losses in pipe flow as well as open channel flow. Third, what would happen to the head loss if the diameter of the pipe is decreased? The length of the pipe is decreased. The head loss will decrease as the length of the pipe decreases, and the head loss will increase as the diameter of the pipe decreases. And the fourth one, what are the two types of energy losses typically associated with the pipe flow? From your experimental results, which one is the most significant loss of head incurred by the fluid flowing along a pipe? The two types of energy losses typically associated with the pipe flow are major head loss and minor head loss. Major head loss happen along the process of fluid flow along the pipe due to friction. Minor head loss happen due to the system of the pipe, which is the type of elbow, valves, and tees used. And that's all from me. Thank you very much.
For conclusion, as a conclusion, we achieve our lab objective, which explain the mechanics of fluid phenomenon in pipe by determining some of the parameters such as heat loss, pipe friction coefficient, Reynolds number. Then we analyze and explain how the parameters related to the loss in the pipe. Hence, it can be concluded that the velocity and Reynolds number increase as the volume flow rate increase for all types of the piping system. However, the friction coefficient will decrease over time as the volume flow rate increase. To be noted, we found out that due to calibration of the apparatus, there is a difference between the measured and calculated data. Thus, improvement in apparatus is needed to evaluate further about the experiment. Lastly, the different configuration of pipe with the different turning of the radius will affect the loss in pipe. This loss can be minimized by proper selection of the pipe size, fitting, and setup of the system.